And another stoichiometry problem for you to master this standard. Now it's time to put together all the different cases that we have studied in the previous problems, so let's read together the statement. Do you dare with it? Let's go.
Binnacle project.
It says, a 40 grams of calcite containing 87% by weight of calcium carbonate is made to react with sulfuric acid with 93% by weight and density of 1.52 grams per cubic centimeter. Calcium sulfate, carbon dioxide, and water are formed. Section A says, calculate the volume of sulfuric acid required to react with the calcite sample. Section B says, calculate the volume of carbon dioxide released at 2 atmospheres of pressure and 25 Celsius degrees. And Section C says, calculate the grams of calcium sulfate obtained. So let's get to it. And the first thing we're going to do is to write the chemical equation, that is calcium carbonate reacting with sulfuric acid in order to obtain calcium sulfate, carbon dioxide, and water. And it's time to balance the equation. One calcium atom on the left, also one on the right. One carbon. 3 plus 4, 7 oxygen atoms on the left, and 4 plus 2 plus 1, also 7 oxygen atoms on the right. 2 hydrogen atoms on the left, and also 2 on the right. And finally, 1 sulfur atom on the left and also 1 on the right. The equation is already balanced. And now let's read together again the statement in order to know what they are giving. And it says that a 40 grams of calcite, this is a little stone of calcite, 40 grams of calcite, containing 87% by weight of calcium carbonate. It means that the 87% of this stone, let's say that is this part that I'm shading, is really calcium carbonate, and the rest of the grams are substances that don't really matter in our equation. So let's calculate the 87% of 40. 87% of 40 grams. And we will obtain the grams of calcium carbonate that are reacting with the sulfuric acid. That is 87 divided by 100 multiplying 40. And let's use our calculator. 87 divided by 100 multiplying 40, which means that 34.8 grams are calcium carbonate, okay? 34.8 grams of calcium carbonate in this 40 grams stone. And now you can see that I've erased the previous calculations, but I've written here the 34.8 grams of calcium carbonate in order to inject the conversion factors and move to the sulfuric acid. Don't forget that section A says, calculate the volume of sulfuric acid required. It says that this sulfuric acid is 93% in mass and density of 1.52 grams per cubic centimeter. And what are we going to do? We are moving from these grams of calcium carbonate to grams of sulfuric acid, and then we will apply this data in order to calculate the volume of sulfuric acid. So let's do it. As always, the first conversion factor helps us to move from grams of calcium carbonate to get into moles of calcium carbonate. With 1 mole will be enough to do this calculation. And now let's add calcium atom 40 plus carbon atom 12 plus 3 oxygen atoms, so 3 times 16. And let's use our calculator to do 40 plus 12 plus 3 times 16, which means 100. If you have in your hand 100 grams of calcium carbonate, you have 1 mole of this substance. Second conversion factor. It will help us to move from moles of calcium carbonate to get into moles of sulfuric acid. And now there comes the stoichiometric coefficients, which are 1 to 1. 1 for calcium carbonate and also 1 for sulfuric acid. And the last one will help us to move from moles of sulfuric acid. With one mole we will be doing this conversion factor to get into grams of sulfuric acid. And it's time to add 2 hydrogen atoms, so 2 times 1 plus 1 sulfur atom, 32, plus 4 oxygen atoms, so 4 times 16, and let's do 2 plus 32 plus 4 times 16, 98. If you have 98 grams of sulfuric acid, you have 1 mole of this substance. And let's put all these numbers in the calculator. 34.8 multiplying 98 and divided by 100, and that's it. We are going to obtain 34.1 grams of sulfuric acid. We will need 34.1 grams of sulfuric acid. And now it's time to know how to obtain these grams of sulfuric acid from this dissolution. It seems that the sulfuric acid comes in the form of dissolution, which means that we have a bottle containing sulfuric acid, but also with water. This is water. And we must calculate the appropriate volume of this bottle in order to be sure that the grams of sulfuric acid is 34.1 grams of sulfuric acid in this bottle. Okay? And we are given the mass percentage and the density. So what are we going to do? Please follow me in this argument. As we have grams of solute, that is 34.1 grams of sulfuric acid, it would be nice if we could know the grams of the dissolution, the grams of the bottle. And what are we going to do? We are using the mass percentage. Okay? We are using this data in order to know the grams of the bottle. And once we have the grams of bottle, we can calculate the volume of the bottle using the density, right? So let's do it. As you all know, percentage of mass. So let's do it. As you all know, the mass percentage, So let's do it. As you all know, mass percentage equals grams of solute, that is sulfuric acid, divided by mass. So let's do it. As you all know, the mass percent equals grams of solute, that is sulfuric acid, divided by mass or grams of dissolution, the bottle, dissolution, multiplying 100. And let's place the numbers in the appropriate So let's do it. As you will know, the mass percent equals grams of solute, that is sulfuric acid, divided by mass or grams of this solution. This solution, the bottle, multiplying by 100. And let's place the numbers on their positions. 93 must be equal to grams of solute, grams of sulfuric acid, 34.1. 34.1 divided by grams of this solution, grams of the bottle, x, multiplying 100. Now we can solve for x. Let's move variable x here, and let's move 93 here. And we have x equals 34.1 divided by 93, multiplying 100. And it's time to use our calculator in order to write 34.1 times 100 divided by 93. We need 36.66 grams of this solution. This solution, the bottle, grams of sulfuric acid plus grams of water must be 36.66. And now that we have grams of this solution, we can use the density in order to calculate the volume of our bottle. And here you have it. Density, that is grams of this solution divided by volume of this solution, that is 1.52 grams per cubic centimeter, must be equal to grams of this solution, 36.66 grams divided by the volume of the bottle. And here we have x equals 36.66 divided by 1.52. We need to take a bottle of 24.12. This is volume, but milliliters, cubic centimeters, liters. Look, cubic centimeters. Be careful with the units. But good news, because cubic centimeters equals milliliters. So we need 24.12 milliliters of sulfuric acid in this solution. This is the solution of section A.
Binnacle project.
Now section B says, calculate the volume of carbon dioxide. Volume of carbon dioxide released at 2 atmospheres pressure, 2 atmospheres, and 25 Celsius degrees. 25 Celsius degrees. But I'm adding 273 in order to convert them in kelvins. 298 kelvins. And what are we going to do? We are using this formula. Pressure multiplying volume equals moles, number of moles, Rydberg constant, that you can read it from the statement, and the temperature. And here you can see that we only need moles of carbon dioxide, moles, not grams. So that's why we are beginning with our 34.8 grams of calcium carbonate. The first conversion factor moves us from grams of calcium carbonate to get into moles of calcium carbonate. And don't forget that in the previous section, we obtained 100. Our second conversion factor will help us to move from moles of calcium carbonate to moles of carbon dioxide. And stoichiometry between these two substances is 1 to 1. 1 to 1. And we are stopping here our train because, as I told you previously, we need moles of carbon dioxide. And 34.8 multiplying 1 and divided by 100, we are obtaining 0.348 moles of carbon dioxide. And now we are using this formula: pressure to atmospheres. The volume is what we are asked to calculate. Number of moles, 0.348. The Rydberg constant, 0.082. And finally, temperature, 298. 298. Now we are using our calculator to do 0.348 multiplying 0.082 multiplying 298 divided by 2, and we will have 4.25 liters of carbon dioxide at the given conditions. Easy, right?
Binnacle project.
And now let's finish our problem by doing the third section, which says calculate the grams of calcium sulfate. And as usually, we are beginning with this 34.8 grams of calcium carbonate. The first conversion factor will move us from grams of calcium carbonate to moles of calcium carbonate. 1 mole equals 100 grams of calcium carbonate. The second conversion factor will move us from moles of calcium carbonate to get into moles of calcium sulfate. And the stoichiometry between these two substances is 1:1, as you can see, 1:1. And finally, our third conversion factor will move us from moles of calcium sulfate. With 1 mole, we will be doing this conversion factor into grams of calcium sulfate. And it's time to add calcium, 40, as you can read from the statement, sulfur, 32, and 4 oxygen atoms, that is 4 multiplying 16. And by doing 40 plus 32 plus 4 times 16 equals 136 grams of calcium sulfate is 1 mole of calcium sulfate. And finally, we have 34.8 multiplying 136 and divided by 100. The result is 47.33 grams of calcium sulfate will be obtained. Easy, right?
Binnacle project.
This problem doesn't have anything new, so I hope you've understood perfectly well every step I've taken. We were given calcium carbonate, but not directly in grams, but in the form of 40 grams calcite containing 87% in calcium carbonate, etc. But using this value, we have obtained the milliliters of sulfuric acid in the form of this solution. We also calculate the volume of carbon dioxide in the form of gas. And finally, we obtained the grams of calcium sulfate. So, if you have understood perfectly well every step I've taken, you are a stoichiometry professional. Good luck! And now, watch a theory video if you think you've gotten lost in some aspects, or skip to the next exercise to continue climbing. And as always, like, turn on notifications and comment. See you soon!